So welcome back, and today we're going to tackle the grade 12 work in this topic, and it's around what we call annuities. So we are on page 14, and let's dive straight in. We ended the last session talking about timelines. Now, annuities. What an annuity is, it's a series of equal, regular payments. And the two reasons we have annuities. One is for the purposes of saving money, and that's called a future value annuity. All right, and the other reason is to repay a loan. A loan or a debt. And that's what's called a present value annuity. We're going to look at both. We're going to start off by looking at future value annuities. So let's look at an example. Mr. Khumalo deposits 300 Rand per month. Right, that's a really common idea in terms of saving. And the reason that people would do that is that we get paid salaries per month. Most people get paid per month. So they would try and save something each month. So he deposits 300 Rand per month for 10 years into an account which pays interest at 12% per annum compounded monthly. All right. Okay, now that 12% per annum compounded monthly is actually 1% per month. And we've chosen that because it's nice and simple for this first one. Right, 1% per month. Okay. Interest is always compounded at the same rate, same frequency. So in other words, the payments are made monthly and the interest is compounded monthly. That's really important. Okay, so let's have a look at what happens here. He makes all these payments, okay? This is payment number 1, payment number 2, payment number 3, payment number 4. We can't fit them all in. Then the last three payments, 118, 119. So if we look at from the back, at the end, this last payment, if we assume we want the balance over here, what's the total at this point? All right. Well, the last payment does not get any interest. All right. That's that payment there. This payment is in the account for 1 month. So remember our formula. It's going to be, sorry, this, I don't know why I wrote 120. The payment is, that's payment number 120, but the value is 300. All right. Now, this payment over here is in the account for 1 month, so it's actually going to get 1% worth of interest, 1 plus 0,01. Right, this payment over here is in the account for 2 months, so it's going to get 2 months worth of compound interest, and so on. The next one's going to get 3 months. Right. So what we've got here, if we look at this is a geometric sequence. We know A, we know R, and we know that there are 120 terms. So our total, if we add all of these up, is going to be A. R is 1,01. That's going to be 120 terms minus 1 over 1,01 minus 1. Okay, let's work all of that out. So, 300. 1,01 to the power of 120 minus 1. And on the bottom we've got 1,01 minus 1. And so it works out to 69,011 Rand and 61 cents. 69,000. All right, and that's the total amount that he's got. Notice each of these payments is in the account for a different amount of time, and each therefore earns a different amount of interest. How much interest did he earn in total? Well, this is quite easy to work out because 120 payments, he contributed, he paid in 120 times 300. Right, now that comes to 36,000 Rand. Right, but he ended up with 69,011 Rand and 61 cents. So the interest is just the difference between those things. There's no other place money is coming from. He's putting money in and he's earning interest. Okay, so the difference between those, right, if we just subtract them, and we can actually subtract them in our heads, it's going to be 33,000 and 11 Rand and 61 cents. Okay, if we turn over, it actually asks us to summarize that here. It says, the interest earned is simply the difference between the final amount and the sum of all the contributions. Okay, we call them contributions, payments basically. Okay, now we're going to do this exact same question again, but we're going to do it with variables in order to create a formula. So now, this time we're investing X, all right? The interest rate is I% per compounding interval. Okay, once again, this last payment, we want the balance over here. What's the total? And so this last payment doesn't actually get any interest. The next one has got 1 period's worth of interest, in other words, 1 plus I. The next one has got 2 periods of interest, 1 plus I to the power of 2. The next one has got, etc. All right, now this is a geometric sequence. All right, so our formula is going to be A is just X, R is 1 plus I, and there are n payments altogether, minus 1 over 1 plus I minus 1. Okay, that is going to be our final answer. And this obviously on the bottom it actually simplifies because we've got 1 plus I to the n minus 1, and on the bottom we've actually just got I. This formula here is called the future value annuity formula. It gets provided in tests and exams, all right, and we'll show it to you again over the page. But what it does is it tells us the future value of n equal payments of X, interest at I% per annum per compounding period. It gives us the balance immediately after the last payment. In other words, the last payment does not earn interest. Right, you might wonder why the formula does that. That is just what it does, and we'll see how we can kind of work with it beyond that. Okay, all right, there it is. That's the formula. Now we're going to use it to solve a couple of problems. Okay, so I'll write the formula down each time. Here it is. F, the future value of some payments is X, 1 plus I to the power of n minus 1 over I. Okay, so I wish to raise 25,000 Rand. So that's how much I want to end up with over a 7-year period, making monthly payments. Okay, and the question is, how much must I invest? What must X be? What's the monthly payment? So now let's have a look at this. This is going to be 1 plus, now my interest rate is 14% per annum. But remember, I want my interest rate per month. So it's going to be divided by 12. 7 years, how many months in 7 years? 7 times 12, 84. Minus 1 over 0.14 over 12. Okay, now we're going to work this out. Okay, let's just have a look. The stuff in the square brackets, all this stuff in the big square brackets is going to be as follows. It's going to be 1 plus 0.14 over 12 to the power of 84 minus 1 over 0.14 over 12. It comes to that, 141.37. Now, so what we've basically got here is we've got 25,000 is 141.37x. What must I do to both sides to get x? Yeah, that's right. I must just take the 25,000 and divide by this number. Right, now remember we want to divide by that exact number, not the rounded off number. So I'm just going to go here, 25,000, because you see if I press all clear and press answer, there's that number. Right, so I'm going to go 25,000 divided by that answer. And we get 176.83 cents. 176.83. And that is the amount that we must pay monthly for 84 months, 7 years, in order to end up with 25,000 Rand. Okay, the next one asks how long will it take to raise some money. There we've got, this time the payments are quarterly, but notice that the interest rate is there. Let's write the formula down again. F equals X, square brackets, 1 plus I to the power of N minus 1 over I. Okay, how long? Okay, so I want to raise 60,000 Rand. That's the total that I want to end up with. The payments are going to be 800 Rand each. Interest is going to be paid at 12% per annum compounded quarterly. So my interest rate is actually going to be 0.03. Okay, and this N is going to be the number of quarters. I don't know what it is yet. And on the bottom I've got 0.03. Okay, now how many variables are left in there? Just one. Okay, so we're going to try and unpack what's happening to N here. First thing we're going to do is we're going to divide both sides by 800, okay? So 60,000 divided by 800 is actually 600 divided by 8. And that equals 1.03 to the N minus 1 over 0.03. We're going to get rid of this fraction on the right-hand side by multiplying both sides by 0.03. So we're going to get 600 over 8 times 0.03. And that's going to be 1.03 to the power of N minus 1. Let's add 1 to both sides, seeing as we're running out of space a bit. Now, all of this stuff here is just a number, right? So we've got our variable in the exponents and when that happens, we're going to use our log function, right? So the final answer, and I'm going to write it up here, is N is going to be log base 1.03 of this stuff, okay? 600 over 8 times 0.03 plus 1. Okay, let's put all that into our calculator. Log base 1.03 fraction button 600 over 8 times 0.03 plus 1. Okay, and we get 40, basically 40 quarters. So N equals 40. Right, so actually 40 quarters, 10 years. Right, that's how long it will take. So we're going to make 40 payments, all right, of 800 Rand. 40 times 8 is actually only 32,000 Rand, okay? 40 payments of 832,000. The rest will come from interest. Okay, right, so let's look at another example before we end today's lesson, and then we're going to give you some to try for homework. Right. I make monthly payments of 500 Rand for 10 years. How much will I have 3 months after making my last payment? Right. Now, remember that this formula gives us the balance immediately after making our last payment. Okay, so let's work out that balance. All right, it's going to be 500. The interest rate is 12% per annum compounded monthly. Now that's 1% per month. So that's 1 plus 0.12 over 12. All right, and it's 10 years, monthly payments, it's 120. Minus 1 over 0.01. That's the 1% per month. Right, that's how much I'll have, and let's just work it out. That's how much we'll have immediately after we make our last payment. Yeah, it's 115,019 and 34. Now the question says, how much will I have 3 months later? And this is now just our normal compound interest formula. This amount is just going to earn compound interest for 3 months. This is not an annuity. This is just a normal leaving the money in the bank. Okay, so what we're going to end up with, that same number, 115,019.34. I won't use that number. I'll use my accurate number off the calculator. 1,01 to the power of 3. Okay, 3 more months. Times 1,01 to the power of 3. And I end up with 118,504.55. 118,504 and 55. Now, remember, good practice, always just read the question, make sure you've answered the whole question. And in fact, we haven't, because the last thing says, how much interest do I end up earning? Well, let's just think about this. This is how much we've ended up with. All right, let's think about how much money we've put in. We've contributed, all right, we've put in 500 times 12 payments per year times 10 years. Okay, so 500 times 12 times 10. Let's work that out. We've put in 60,000 Rand. And we've ended up with 118,504.55. The difference is interest. So our interest calculators all over the show. Sorry, our interest is just going to be the difference between these numbers. We can actually do it in our head. It's actually going to be 58,504 Rand and 55 cents. Okay, right, now we're going to stop there. All right, it's the end of today's lesson. But before the next lesson, we want you to try these questions. There are 4 of them. In fact, there are 7 of them, 8 of them, 9 of them, 10 of them. There's lots of them. We're going to go over them next time. We might not get to go over all of them next time, but we hope you're going to try as many of them as possible. Here is the formula that you're going to need. All right. Okay, enjoy the rest of your day. We'll see you later.